For the plurality with elimination method, we essentially have the goal here of creating a majority as best we can. If we start out from our set and get a majority, great, we're done. But often, especially if you have a whole bunch of options, that's not going to happen. So what we do is, for this method, we take all of our options and remove the one that is the least popular. That is, remove the one with the least number of first place votes, take that out of there, and pull everything up by one spot around that rearrangement. We don't kick out the ballots where it's first. We take out that option from the ballot and move everything up to fill the space, where this is also called an instant runoff election, and variations on it are used by both the International Olympic Committee to select host nations for the Olympics, as well as the Academy of Motion Picture Arts and Sciences to determine Oscar winners, where this has similar problems to the board account method in that you can get results where you don't have a preferred option that would normally win head-to-head based on what ends up getting removed over time. And then also, as we're going further and further with this, we do get more and more complex things logistically, and we're leading ourselves into situations where it'd be easier and easier to mislead and confuse voters. And as much as we would like all of our voters to have all of the information they need and a very, very clear picture of what it is they're picking, the more that goes into how this is determined, the more likely it is that certain mistakes may occur. But anyway, what we're going to do here is think about what would happen with those cities, with that city example, yet again, talking about plurality with elimination, where if we start from our preference table where we began originally, we can see that the most we have are votes for Paris, which is 14 out of 37. We need at least 20, or at the very least, we need at least 19. If we have more than 20, that'd be good too, but the point is we're just not quite there yet. So what we do for this method is look here and see that Rome, of our options, has received the least number of first place votes. It only got 4 from that fourth category of people who really wanted to go see the Colosseum, I guess. And as a result, because it's the least popular, the least chosen first place, we remove it from the ballot, which pulls all of the things up around it, giving us a new preference table. Where here, because we removed 1 on the 14 that favored Paris, both St. Petersburg and Tallinn moved up 1 place. On the ballot where Rome was second, Tallinn and Paris moved up 1 place, where Tallinn was first. St. Petersburg stayed second, and Paris moved from 4th to 3rd. And where Rome was first, all 3 moved up 1, and then in that last ballot, only Paris moved up because Rome was the 3rd choice. And looking at this, we're starting to get Tallinn making a bit of a comeback, as even though there still isn't a majority here of those 37 votes, we still have Paris in the majority because Rome was removed from the 4 in that 4th category. Tallinn now wins those 4, so we have a organization where Paris got 14, Tallinn got 12, and Rome got 11, so we would end up removing Rome from the options at this step because we still don't have a majority, to get an even simpler preference table that's just between Paris and Tallinn, where again, because a lot of people didn't want to go to Paris, I guess they heard about Paris syndrome and were very scared of it, Tallinn actually ends up inheriting the majority in this case, despite the fact that most people had it as their 2nd, 3rd, or even 4th choice, as the hopeful Parisians did. It would end up getting a majority of the vote with 23 after these eliminations. So, for this election, we will have a bit of an upset that Tallinn, Estonia wins. And that's where they would be going for their trip. And then the last method we have here, the last one we're going to look at, is probably our deepest computationally. It's our most complex in terms of how to pull our pieces together. So be careful here, go through this one slowly, but understand that because it requires a little bit of stuff that's technically just outside of what we cover in this class. I'm not going to ask for too much from it, but we should still see at least once the pairwise comparison method.